All right, here's the second video to finish the quiz review. I only get a max of 15 minutes using this program, so we'll get through the rest of these pretty quickly. At the Coulterville Country Club, 78% of members play golf and are college graduates, so that's both. They do both play golf and they graduated college, 78%. And 85% play golf, so golf alone. If a member is selected at random, find the probability the member is a college graduate given the member plays golf. So we need to think about the formula we got in the Google Meet on Friday for conditional probabilities. So we're going to find the probability they're a college graduate. I'll put CG for college grad, given they play golf. And if you look in the formulas for conditionals to find this probability, on top of the fraction, it's going to be the probability they do both. So the probability they're a college grad, so CG, and play golf, which remember, I was given that probability. So they both are college graduate and they play golf, divided by the probability they play golf. So the bottom of my fraction will be golf. And I mentioned Friday in the Meet, kind of looks like a divide sign. So in the formula, it's what goes on the bottom. So here's the probability of golf. They gave us those two percentages. So I'm just going to divide them. So it's going to be 0.78 divided by 0.85. And that'll give us the probability they're a college graduate given they play golf. And that's 0.918. I'm just going to kind of save on my writing here. I'm writing with my finger. I'm just going to read this and kind of explain the formula in words and then just divide the fraction. So the probability Sam parks in a no parking zone and gets a parking ticket. So he parks in the no parking zone, he gets a parking ticket, is 0.08. The probability Sam parks in a no parking zone is 0.3. What is the probability he gets a ticket given no parking zone? So here I'm doing probability of a ticket given he was in a no park zone. So if I apply the same conditional formula, and in our notes it's A given B, but here we have ticket given no parking zone. So that formula on top is going to be just like this one above, but instead of college grad and golf, it's going to be the probability he gets a ticket and parks in a no parking zone, which we were told was 0.08, and then divided by the probability he parks in a no parking zone. So again, whatever second or after the given line is under the divide. So here that's going to be 0.3. And if I divide 0.08 divided by 0.3, that gives me my conditional is 0.267. And the next question will have a conditional as well, but just in the form of a two-way table. So last one on here. Here's a two-way table. It gives information. A gift basket store had the following pre-made baskets containing following combinations in stock. So these gift baskets, they either have coffee or tea, or they could contain cookies, mugs, and candy, or both. Like, for example, here, this 20, that would be the number of baskets they have that contain mugs and tea. This 25 is the total baskets that contain candy. So that's what this table is giving us. Let's see what we're asked to find. So the first thing is the probability. We pick a basket, and it contains tea given it contains mugs. And I mentioned in the Google Meet Friday that two-way tables give the easiest conditionals because the given is the row or column you're focused on. So here I'm focused on this column. I don't care about anything else. So given there are mugs, so out of the 30 that contain mugs, what's the probability they contain tea? Well, 20 out of the 30 baskets with mugs contain tea. And again, I always reduce my fractions. That gives me 2/3. Next one, probability I pick a basket has coffee or candy. So here are my baskets with coffee. Here are my baskets with candy. So there's two ways you can do this. Let me highlight those rows. So here's my coffee. Those are my coffee baskets. And what was it, coffee or candy? Here are my candy baskets. So all of these contain either coffee or candy. Now how you can do it is you can add these up. You can simply add the numbers inside the table, not the totals. So those 4 numbers contain coffee or candy, and I don't count the overlap. So I could do 30 plus 10 plus 10 plus 15. That's going to be 65 out of 100. So one way I could find it, if I do the green numbers, pick the same pen in green. So if you do the green numbers, you get, I think I said 65 out of the 100 total. I'll reduce this in a second. The other way is you could use the yellow numbers. So if you use the yellow numbers and the formula, that means you would take the probability they contain coffee, which is 55 out of 100, 55 out of 100, plus the probability they contain candy, that's 25 out of 100, but when you do that, you counted the overlap twice. So if you use the 55 and the 25, that means you counted this overlap twice. So I'm going to have to subtract that. And I should get the same probability. So let's see. 55 and 25, that is 80, I believe. And then 80 minus 15, yes, that's going to give me 65. So I still get 65 over 100. Either way is fine to find that probability, and 65 over 100 should reduce to, oops, they only divide 5, 13 over 20. Or you can make it in a decimal. And last one, tea and cookies. So we're only picking one basket, so no multiplying here. Okay, tea and cookies, I'm picking one basket, so there's no independent, dependent, anything like that. This and means both. So what's the probability that I pick from these 100 baskets and I get one that has both tea and cookies? Well, let me see, tea and cookies, that's right here, that's this 20. So 20 out of the 100 baskets have both tea and cookies. And if I reduce that, 20 over 100 will reduce to 1/5. All right, I hope this helps. The quiz tomorrow will have similar questions, similar type, just a few more because they're not broken down by A, B, or C. It'll seem like more questions. Good luck and see everybody after Christmas.